Classification of lipids. Lipids, a variety of naturally occurring organic compounds classified together on the basis of common solubility properties. Insoluble in water. Soluble in aprotic organic solvents including diethyl ether, dichloromethane and acetone. Lipids include triglycerides, fats and oils, cholesterol, steroid hormones, and bile acids. Phospholipids, prostaglandins, fat-soluble vitamins, saturated fat, unsaturated fat, triglycerides. Triglyceride, an ester of glycerol with 3 fatty acids. Saturated triglycerides are more commonly known as fats. Unsaturated triglycerides are more commonly known as oils. Fatty acids. Fatty acid, a long, unbranched chain carboxylic acid. Nearly all have an even number of carbon atoms, most between 12 and 20 in an unbranched chain. The 3 most abundant are palmitic acid, 16:0, stearic acid, 18:0, and oleic acid, 18:1. #C, #double bonds. In most naturally occurring unsaturated fatty acids, the cis isomer predominates, the trans isomer is rare. Unsaturated fatty acids have lower melting points than their saturated counterparts. The greater the degree of unsaturation, the lower the melting point. At room temperature, most saturated fatty acids are solids and most unsaturated fatty acids are liquids. The greater the degree of unsaturation, the lower the melting point. Note these naturally occurring unsaturated fatty acids have cis geometry around their double bonds. Triglycerides, again. The physical properties of triglycerides depend on the properties of their fatty acid components. Melting point increases as the number of carbons in their hydrocarbon chains increases and as the number of double bonds decreases. Triglycerides rich in unsaturated fatty acids are generally liquid at room temperature and are called oils. Triglycerides rich in saturated fatty acids are generally semi-solids or solids at room temperature and are called fats. The lower melting points of triglycerides rich in unsaturated fatty acids are related to differences in their three-dimensional shape. Hydrocarbon chains of saturated fatty acids can lie parallel to each other with strong dispersion forces between their chains. They pack into well-ordered, compact crystalline forms and melt above room temperature. Because of the cis configuration of the double bonds in unsaturated fatty acids, their hydrocarbon chains have a less-ordered structure and dispersion forces between them are weaker. These triglycerides have melting points below room temperature. Reduction of triglycerides. The process of converting oils to fats is called hardening and involves catalytic reduction of some or all of an oil's carbon-carbon double bonds. In practice, the process is controlled to produce a fat of a desired consistency. The resulting fats are sold for cooking, Crisco, Spry, and others. Unsaturated fat, oil. Saturated fat, solid. Reduction of triglycerides. Margarine and other butter substitutes are produced by partial hydrogenation of polyunsaturated oils derived from corn, peanuts, and soybeans. Catalytic hydrogenation is to some degree reversible. Hardening results in the isomerization of some cis fatty acids to trans fatty acids, resulting in the hardening of an oil. Current nutrition science states that trans fatty acids are to be avoided as much as possible. Soaps and detergents. Natural soaps are prepared by boiling lard or other animal fat with Na-O-Li, in a reaction called saponification, Latin, sapo, soap, to have the fat undergo base-catalyzed ester hydrolysis. Soap is the sodium salt of a fatty acid. Soaps clean by acting as emulsifying agents. The long hydrophobic hydrocarbon chains of soaps are insoluble in water and tend to cluster in such a way as to minimize their contact with water. The polar hydrophilic carboxylate groups remain in contact with the surrounding water molecules. Driven by these two forces, soap molecules spontaneously cluster into micelles, a spherical arrangement of organic molecules in water clustered so that their hydrophobic parts are buried inside the sphere and their hydrophilic parts are on the surface of the sphere and in contact with water. When soap is mixed with water in soluble grease, oil, and fat stains, the nonpolar parts of the soap gels dissolve nonpolar dirt molecules and they are carried away in the rinse water. Soaps form water-insoluble salts when used in water containing Ca2+, Mg2+, and Fe3+ ions, hard water. These insoluble salts are sometimes known as soap scum. Detergents. The design criteria for a synthetic detergent are a long hydrocarbon tail of 12 to 20 carbons, a polar head group that does not form insoluble salts with Ca2+, Mg2+, or Fe3+ ions. The most widely used synthetic detergents are the linear alkyl benzene sulfonates, LAS. Also added to detergent preparations are foam stabilizers, bleachers, and optical brighteners. Soaps and detergents are part of a class of compounds called surfactants. Surfactants affect the properties of a solution by lowering surface tension. For example, between the solution and grease. The properties of a surfactant depend on the charge on the molecule. There are three broad categories of surfactants: anionic surfactants, cationic surfactants, non-ionic surfactants. Anionic surfactants, cationic surfactants, non-ionic surfactants. Phospholipids. Phospholipids are the second most abundant group of naturally occurring lipids. They are found almost exclusively in plant and animal membranes, which typically consist of 40% to 50% phospholipids and 50% to 60% proteins. The most abundant phospholipids are derived from phosphatidic acid, which is glycerol esterified with 2 fatty acids and 1 phosphoric acid. Further esterification with a low molecular weight alcohol with a quaternary amine gives a phospholipid. The three most abundant fatty acids in phosphatidic acids are palmitic acid, 16:0, stearic acid, 18:0, and oleic acid, 18:1. A phosphatidate and a phospholipid. Lipid bilayer. When placed in aqueous solution, phospholipids spontaneously form a lipid bilayer. Polar head groups lie on the surface, giving the bilayer an ionic coating. Non-polar fatty acid hydrocarbon chains lie buried within the bilayer. This self-assembly is driven by two non-covalent forces: hydrophobic effects, which result when non-polar hydrocarbon chains cluster to exclude water molecules; electrostatic interactions, which result when polar head groups interact with water and other polar molecules in the aqueous environment. Biological membranes. Fluid mosaic model. A biological membrane consists of a phospholipid bilayer with proteins, carbohydrates, and other lipids embedded on the surface and in the bilayer. Fluid signifies that the protein components of membranes float in the bilayer and can move freely along the plane of the membrane. Mosaic signifies that the various components of the membrane exist side by side, as discrete units rather than combining to form new molecules and ions. Steroids. Steroids, a group of plant and animal lipids that have the tetracyclic ring structure shown below. Features common to steroids. The fusion of rings is trans and each atom or group at a ring junction is axial. The pattern of atoms or groups along the ring junctions is nearly always trans-anti-trans-anti-trans. The steroid system is nearly flat and quite rigid. Most have axial methyl groups at C10 and C13. Examples of steroids: cholesterol, progesterone, estrone, estrogen, testosterone, androsterone, cortisone, prostaglandins. Prostaglandins, a family of compounds that have the 20-carbon skeleton of prostanoic acid. Note the 5-membered ring in the middle. Prostaglandins are not stored in tissues as such, but are synthesized from membrane-bound 20-carbon polyunsaturated fatty acids in response to specific physiological triggers. One such polyunsaturated fatty acid is arachidonic acid. among the prostaglandins synthesized biochemically from arachidonic acid RPGE2 and PGF2. Both hormones are used to induce labor in pregnant women. Fat-soluble vitamins. Vitamins are divided into two broad classes on the basis of their solubility. Those that are fat-soluble, and hence classified as lipids. Those that are water-soluble. The fat-soluble vitamins include A, D, E, and K.